Welcome to the DX Today podcast, where you get facts without the hype. Okay, let's unpack this. Today, we are undertaking a really critical deep dive. We're analyzing the massive economic correction that's happening right now across the entire AI startup market. It's a phenomenon that really analysts are now universally calling the AI vendor shakeout.
And this is absolutely necessary context for every single organization out there. I mean, for every enterprise leader, every procurement team that's currently using AI.
It feels like it came on so fast.
It did. The last 18 months or so, 2023 and 2024, saw what a lot of people rightly called the Cambrian explosion of generative AI.
Right. Thousands of new companies, VC money everywhere, just limitless possibilities, it seemed.
Exactly. But that chaotic innovation phase, it's over. We are now moving into a harsh Darwinian selection event that's going to play out over the next 18 to 24 months.
And you're saying this isn't just a market cooling off?
No. I really want to stress this. This is not a gentle cooling. This is a structural market rationalization, and it's being driven by fundamental, frankly, unavoidable economics.
And this volatility is coming at just the worst possible time for enterprises because adoption is, well, it's massive.
It's huge.
We sourced some data showing that 44% of U.S. businesses are now actively paying for AI tools.
And just think about that number for a second.
It's an explosive jump from, what, just 5% in 2023?
A tiny 5%. It shows this isn't a pilot program anymore.
No, we're talking about serious embedded workflows. And the average contract value we're seeing, it's sitting around $530,000.
$500,000.
$500,000 of significant sunk investment. And that entire investment is currently built on an alarmingly fragile foundation. A foundation made up of, what, thousands of these VC-subsidized startups.
And that foundation, that's the thing that keeps me up at night.
Yeah.
The failure of an AI vendor, for you, the enterprise user, poses these unique risks that go far, far beyond the pain of a traditional software bankruptcy.
Okay, so what's the difference? With a normal SaaS company, they go bust, you migrate your data, find a new tool. It's a headache, but it's manageable.
Right. But when an AI vendor fails, you face the very real risk of orphaning your proprietary fine-tuned models.
Models that might contain our institutional knowledge.
The very institutional knowledge that you may have helped train, you also risk creating these insidious, unmonitored zombie API security vulnerabilities that just linger in your integrated systems.
And you mentioned something even worse.
Potentially, yes.
Okay.
Worst of all, you risk your most sensitive data being sold off as an asset to creditors during a fire sale liquidation.
Okay, so our mission for this deep dive is crystal clear. We have to move past the hype and really understand the cold, hard macro drivers of this instability.
The physics of failure, as you put it.
The physics of failure, I like that. And then, most critically, provide a rigorous, actionable framework for resilience. We are shifting from the chaotic, fast-moving era of experimentation
straight into the necessary, disciplined era of industrial AI.
Let's start exactly where this correction begins, with the money. Because that is the root cause of all this instability.
It always is.
And here's where it gets really interesting to me. Why are so many of these technically impressive, often brilliant companies, why are they so financially untenable?
The answer comes down to two major forces, what we're calling the burn rate crisis, and something the industry is labeling GPU poverty.
Okay, let's break that down.
The cost structure of AI is just fundamentally different from nearly any other software segment we've seen in the last, 2 decades?
You mean compared to traditional SaaS?
Exactly. In traditional SaaS, your primary cost of goods sold, your COGS, are things like, basic cloud hosting, support staff salaries, maybe some minor storage fees.
And that structure has always allowed for really healthy gross margins.
Oh yeah, 70%, 80%, easily.
Yeah.
But the moment you introduce generative AI into your product, that entire economic equation just gets turned on its head.
And you're talking about the inference cost trap, right? This scales completely differently than a fixed fee subscription.
Precisely. Inference is the computational cost of running the model every single time a user interacts with it.
Every prompt, every response.
Every image generation, every data query, every single one incurs a real hard cost. And this is the critical vulnerability for these application layer startups that are relying on external APIs from, say, OpenAI, Anthropic, or Google.
So if I build a tool on GPT-4 and my users absolutely love it and use it 10 times more than I expected, my cost just went up 10 times too.
Exactly. Your inference cost scales linearly with usage volume. But your revenue per user, if you're on a fixed monthly subscription plan, that stays static.
So you're stuck.
You're completely stuck. Even if you have aggressive per-seat pricing, that doesn't necessarily scale with the intensity of usage. This forces these startups to aggressively subsidize these massive compute costs just to gain market share.
They're essentially selling the service at a loss.
They are. They're selling at a loss, hoping to grow fast enough to secure the next bigger round of VC funding before the money runs out.
That's the classic definition of upside-down unit economics, where it costs you more to service a customer than the revenue you get from them. But what makes the overall burn rate so high for these companies specifically?
Well, it's not just those variable inference costs, it's the fixed costs too. To stay competitive, these companies need high-end ML talent.
And those salaries are astronomical.
Oh, easily 50% to 100% higher than for a traditional software engineer. And crucially, they also need dedicated GPU access. That often means signing expensive long-term reservation contracts with cloud providers like AWS or CoreWeave.
Which are huge liabilities on the balance sheet.
Massive fixed liabilities.
Correct.
So you combine those commitments with that high variable inference tax, and it means that these AI-driven companies are sustaining monthly burn rates from $100,000 to, in some cases, over $500,000.
That's structurally just. It's on a different level than their non-AI SaaS peers.
Completely different. And that leads directly to what we're calling the dangerous burn multiple. This metric, the burn multiple, should be the very first number every enterprise procurement team asks for.
It really should be. I mean, it's the efficiency metric, right?
It is. It measures how much cash a company is burning for every single net new dollar of annual recurring revenue ARR that it generates.
So for a healthy, sustainable startup, you're looking for a burn multiple below 1.
Below 1.0x is top tier. That means you're burning less cash than the new revenue you're bringing in. But industry data shows a substantial portion of the AI sector is operating above 3.0x.
Okay, let's use that coffee shop analogy to make this really visceral for the listener.
Okay, sure. So imagine you're running a brilliant new coffee shop. Your coffee's the best in town. That's your superior AI model. But for every $5 latte you sell,
That's my $1 of ARR.
right, it costs you $15 in beans, electricity, and the rent on your fancy espresso machine. That's your burn. You are relying on investors to cover that $10 difference.
A burn multiple of 3.0x means for every new dollar of revenue, they are burning $3 of VC cash.
$3 of investor money goes up in smoke. And in the tight capital markets we're expecting in 2025, that is a structural death sentence. Investors are now ruthlessly scrutinizing efficiency and companies operating at that multiple. They have no clear path to profitability without just massive, crippling cuts.
And all that investor scrutiny is only accelerating the collapse of the Rule of 40, which for years was the golden health heuristic for soft companies.
The Rule of 40 was the gold standard, absolutely. It stated that a healthy company's growth rate, when you add it to its profit margin, should be more than 40%.
Right, it was the quick way investors judged if a company was properly balancing aggressive growth with, sound financial management.
Exactly. If you were growing at 50% but losing 10% cash, your Rule of 40 was 40. You were deemed healthy. It meant your growth was efficient enough to justify those losses.
But the AI sector has completely annihilated this benchmark because their costs are just so out of control.
It's been completely annihilated. The data shows the median Rule of 40 for enterprise software startups with over $50 million in revenue. It plummeted to just 9% in 2024.
9%. I mean, think about the implications of that.
It's down from a much healthier 21% back in 2021. This means the average growth rate plus their profit margin is stuck in the single digits. Only 13% of companies even meet that traditional 40% threshold anymore.
The safety harness has just snapped.
It has. This isn't just an economic slowdown. It signals a deep structural deterioration in the sector's ability to achieve efficient growth. And it's driven almost entirely by that GPU tax and the inference costs we just talked about.
And that structural deficiency funnels all the power and all the capital right into the hands of the giants.
Right to the hyperscalers.
Which brings us to the dominance of compute power and the hyperscaler moat. You're talking about Microsoft, Alphabet, Amazon, Meta.
Yes. The industrial era of AI is defined by brute force capital expenditure. It's a game of scale that startups simply cannot win.
And the numbers are just staggering.
The hyperscalers are projecting a combined capex of $320 billion in 2025. That money is dedicated almost entirely to building out AI infrastructure new data centers, buying up every single available high-end GPU, securing massive renewable energy sources to power it all.
No startup can match that, no matter how clever their algorithm is.
Not even close. So the dynamic becomes circular and self-reinforcing. VC money flows into these startups to fund innovation.
But that money immediately cycles right back out to the cloud giants for GPU access.
That's the structural consolidation dynamic in a nutshell. Every startup that tries to train a proprietary foundation model has to pay a tax for GPU access to AWS, GCP, or Azure, and every application layer startup running inference pays a similar ongoing API tax.
So a huge chunk of all VC funding in AI is just getting recycled.
A staggering portion is immediately recycled back to those platforms as compute fees. This cost structure inherently favors the platform owners. They have the internal capacity, they own the entire stack, and they can seamlessly integrate AI features into their existing enterprise suites and undercut independent vendors on price.
It sounds like the VC industry is, in a weird way, unintentionally funding the growth of the very giants they're trying to disrupt.
In many ways, yes. They are funding the development of features that the hyperscalers can later just absorb for free, while at the same time ensuring the cloud giants receive a guaranteed revenue stream to build the infrastructure that guarantees their dominance for the next decade.
Right.
What's fascinating here is that failure isn't always a messy public bankruptcy, though we will certainly see plenty of those.
You're right.
Sometimes failure is far more insidious for you, the enterprise buyer, and that's the acqui-hire.
This is where the acquiring company is buying the talent, not the product, right? It seems to be driven by the acute scarcity of top-tier AI research talent.
That is the core driver. The market for engineers who can build cutting-edge foundation models is incredibly tight. It's often easier, faster, and cheaper for a hyperscaler to just buy a company's entire engineering bench, the 20 or 30 most critical technical minds, than to try and hire those individuals one by one through a normal HR process.
And critically, the acquiring company often views the startup's existing product, the thing you, the customer, paid for and rely on, as a distraction.
It's baggage. They want the people, not the baggage of supporting a legacy product.
And this whole approach is also a very calculated move to get around antitrust scrutiny, which is so intense right now around the biggest tech firms.
Exactly. By structuring the deal as a talent license and an IP license, rather than a full corporate merger, they can often avoid the intense, multi-year antitrust review that a formal acquisition would trigger in the US, Europe, and elsewhere. They hire the people, license the valuable IP, and leave the corporate shell intact, but, completely hollowed out.
To make this acquirer risk really concrete, let's look at the Inflection AI precedent. It feels like the perfect archetype of this behavior.
Oh, it is. Inflection was a huge, high-profile player. They had raised $1.5 billion. They built Pi, which was a pretty popular consumer chatbot. But Microsoft recognized the real value wasn't in the chatbot itself or its user base. It was in the world-class team that built it.
So they just hired them.
They hired the co-founders, Mustafa Suleyman and Karen Simonian, along with the vast majority of their technical staff.
And the mechanism was this massive licensing agreement. The corporate entity of Inflection AI didn't technically cease to exist.
Right, but its vital organs were removed. The deal left Inflection as a hollowed-out entity. It retained some physical assets, maybe some secondary IP, but its original leadership, its technical vision, its core roadmap, it all vanished overnight.
So the remaining company had to pivot entirely.
They did. They pivoted to focus on enterprise API models, leaving their original user base and any potential enterprise partners they may have had, with no clear service commitment or path forward. Just think about the irony there.
$1.5 billion in capital.
And the most valuable asset they created was a Rolodex of engineers that were simply absorbed by a competitor.
We saw an almost identical pattern with the Character.ai and Google deal, didn't we?
A very similar script. Character.ai, another major consumer AI success story, entered into a huge licensing agreement, reportedly valued at $2.7 billion, with Google. At the same time, its co-founders returned to Google DeepMind, which was their former employer.
And then came the strategy shift.
Of course. Subsequently, Character.ai announced it was moving away from developing its own proprietary foundation models and towards relying heavily on third-party infrastructure. The pattern is clear. The talent goes home to the giant, and the startup's core value proposition, its technical independence, and its roadmap is functionally destroyed.
And the devastating impact for enterprise customers here is crucial because, as you said, it's worse than a normal bankruptcy.
It is. In a traditional bankruptcy, a trustee is appointed. They try to sell the assets to a new operator who has a clear incentive to maintain the service and the customer base to get value from it.
But with an acquire.
With an acqui-hire, you often get an immediate hard product shutdown, or it enters a permanent maintenance mode. The product just sits there, but no one is developing it, no one is securing it, no one is fixing bugs. You're left with no one to call.
So you're forced into a chaotic, short-notice migration.
A migration you didn't plan
Mm-hmm.
for a mission-critical workflow that was built on that seemingly robust startup product. And the lack of a legal trustee means you have less leverage and far less notice than you'd get in a typical Chapter 11 filing.
This volatility brings us directly to a huge technical challenge for procurement teams. How to differentiate between a genuine, defensible technology platform and a thin wrapper.
Yes.
A significant portion of that 2023-2024 boom produced applications that are just highly susceptible to obsolescence and ultimately failure. We need to talk about wrappers.
The ability to tell a wrapper from a platform is, perhaps, the single most important piece of technical due diligence you can conduct right now. We define a wrapper as an application that derives its core intelligence, its core value proposition, almost entirely from a third-party foundation model, whether that's GPT-4, Claude, or Gemini.
So it's completely reliant on that external API for intelligence.
Completely. The only thing it provides is maybe a slightly better user interface or some basic workflow integration layered on top.
So their core competitive edge isn't the intelligence itself, it's just the packaging. And that fragility brings up the existential threat of feature subsumption, or what everyone in the industry calls Sherlocking.
It's a fantastic metaphor. It comes from Apple, who would often Sherlock successful third-party apps by just incorporating those exact features natively into the iOS operating system, rendering the original app redundant overnight.
And in AI, this threat is magnified.
Oh, it's magnified by a factor of 10 because the foundation model providers, the massive hyperscalers, are aggressively moving up the application stack.
Yeah.
They're looking at what all these wrappers are doing and saying, hey, we can do that too, and we can offer it for free.
And the classic chat with PDF tool is the canonical example of this, isn't it?
Absolutely. A year ago, many startups were founded solely on that premise. Let users upload a PDF or a proprietary document and ask questions about it. This was built using basic retrieval augmented generation, or ORAGE, techniques applied via a third-party API.
But then OpenAI made one move.
One move. They introduced native file upload capabilities directly into ChatGPT Enterprise. And the entire value proposition for dozens of those startups just evaporated overnight.
The platform owner absorbed the feature. Why would an enterprise pay for a separate wrapper anymore?
They wouldn't. The risk is that one simple feature update from a hyperscaler renders the startup completely irrelevant, instantly leading to a death spiral of customer churn and financial failure.
It sounds like we can't just trust the vendor's marketing slide about innovation. We need hard technical indicators. So how can a diligent procurement team differentiate a high-risk wrapper from a defensible platform?
You have to look under the hood at the technical architecture. Let's break down the key areas. First, look at model dependency.
Okay, so a high-risk wrapper relies exclusively on one or two public APIs. If OpenAI goes down, their entire product goes dark.
Exactly.
Mm-hmm.
A defensible platform, on the other hand, uses what we call hybrid orchestration. It might use proprietary, smaller models for specialized, cost-sensitive tasks. It might use open-source fine-tunes for high-volume work. And it will probably use multiple external APIs, OpenAI, Anthropic, Cohere, for general reasoning and comparison.
So that hybridization gives you true failover resilience.
It does. The second indicator is the differentiation source. If the wrapper's value is purely the UI UX, what you call workflow sugar, it's easily copied. Correct. A true platform's value is built on something proprietary that is very hard to replicate. This could be a proprietary data moat, a unique data set that took years to assemble. It could be specialized fine-tuning weights, the product of training an existing model extensively on their own data.
Or it could be some highly complex proprietary logic.
Exactly. Proprietary agentic reasoning logic that governs how multiple models communicate and solve multi-step problems. If they only offer a prettier interface, they're not defensible.
And the third indicator naturally follows: switching costs. If I'm using a wrapper, my switching costs are super low. I just copy my prompt history and move to the hyperscaler's native tool.
Exactly. If you're using a true platform, your switching costs should be prohibitively high because the system has accumulated institutional memory over months or even years.
And that memory isn't just stored data.
No, it's accumulated knowledge embedded in specialized models, customized workflows, and complex integrations that are unique to that vendor. If those switching costs are low, you should assume the vendor is disposable.
This brings us to the prompts versus fine-tuning litmus test, which feels like the most critical question for any enterprise buyer to ask. And let me stress this point. Prompt engineering, writing clever instructions, system prompts, or persona definitions is not a defensible moat.
It is entirely not. Prompt engineering is easily replicated, it's easily leaked, and it's transferable. If your competitor sees your output, they can reverse engineer your prompt. And worse, a new model release from OpenAI often breaks all your old prompts anyway.
So defensibility requires actual fine-tuning.
It does. Fine-tuning means actually updating the weights of the foundational model using your specialized proprietary datasets. That creates a truly unique asset that performs a specific enterprise task far better than any general model ever could.
So if I'm the enterprise buyer, I need to push past the marketing jargon like proprietary IP. What are the specific probing technical questions I should be asking a vendor to figure out if they're actually fine-tuning or just prompt engineering with RG?
You need to demand specific, verifiable evidence. First you ask, are you fine-tuning your own models or are you relying solely on RAG for context injection?
And RAG is easy. Fine-tuning is hard.
RAG is easy, fine-tuning is hard, expensive, and defensible. Second, push them on the financial implications. If OpenAI changes their API pricing, deprecates a model, or alters their content policy tomorrow, how does that impact your service delivery and our contract price?
If they say they have to pass that price hike straight on to me, they are a high-risk wrapper. If they say they can switch to an alternate model with minimal disruption, they're probably a platform.
Precisely. And the third most critical question, do you own the fine-tuned model weights, or are they hosted and controlled by a third party? Because if the weights that contain their unique intelligence are hosted and controlled by AWS or Azure, they do not own their destiny, and you are inherently exposed to the hyperscaler's terms.
And you need proof.
You need proof. Ask them to prove the training happened. Show us the loss curves from your training runs, or what is the size of your proprietary evaluation dataset? If they can't provide these technical artifacts, they're likely just a glorified prompt engineer. Okay, now let's look at the consequences of these financial and technical failures, starting with the immediate security fallout.
Right.
The failure of a wrapper startup, particularly one that's integrated deeply into your enterprise systems, often creates this unique and persistent security risk we call the zombie API risk.
That sounds like a terrifying vector for an attack. What are the practical implications of a zombie API?
A zombie API is an endpoint that was integrated into your production environment, maybe for data classification, summary, or translation, but is now completely unmaintained because the startup failed or was acqui-hired and shut down.
So it's just sitting there.
It's just sitting there.
Yeah.
These endpoints may remain active but unmonitored by the vendor, or they may simply vanish without warning, breaking critical business functions.
Yeah.
But the biggest danger is the creation of orphan secrets.
These are the API keys or authentication tokens that were hard-coded into enterprise systems when the initial integration was set up and are now totally forgotten.
Exactly. When the startup goes bankrupt, its infrastructure might be sold off to a third party, or worse, compromised by an attacker who's just looking for low-hanging fruit. Those lingering forgotten credentials, the orphan secrets, can provide lateral movement for attackers into your network, especially because your internal security team has likely stopped monitoring a vendor that has technically ceased to exist.
And you mentioned orphaned agents as well.
Yes, adding to this complexity, you have the problem of orphaned agents. These are autonomous AI systems, perhaps doing internal data categorization or transaction processing, that are now running without any human oversight or vendor maintenance. If these agents were deployed under specific compliance policies, their unsupervised continuation can lead to major, quiet violations of your data governance rules without anyone realizing the breach until it is far, far too late.
Let's break down the 3 common collapse scenarios we're seeing in the market. Failure mode A, the pivot. And our case study here is the fate of Jasper AI.
Jasper was, for a time, the definitive generative AI darling. They raised $125 million at a $1.5 billion valuation back in 2022 by providing AI writing templates, largely aimed at prosumers and SMBs.
But then ChatGPT launched.
And the moment ChatGPT launched its free and low-cost functionality, Jasper's competitive moat was instantly breached. Their entire customer acquisition funnel just dried up.
So they had to execute a dramatic, painful pivot to survive.
They shifted their focus entirely upmarket, away from the individual writer and toward large enterprise marketing teams trying to sell complex, customized workflow solutions. And this pivot required immense internal upheaval. It came with large-scale layoffs.
They had to jettison staff supporting the old business model.
Exactly. The original founders left, and they took a steep 20% reduction in their internal valuation.
So what does that kind of internal chaos mean for the enterprise customer who signed on for the original vision?
It creates three major impacts that you need to watch for in any distressed vendor. First, feature discontinuation. As the vendor throws all available resources at their new enterprise segment, the legacy tools used by their original customers are often neglected, unpatched, or intentionally deprecated to save on inference costs.
Second, support must take a nosedive.
Support degradation, absolutely. Layoffs almost inevitably hit customer success and support teams first. That leads to massive backlogs, slower response times, and unaddressed bugs. And third, pricing volatility. Desperate to fix their upside-down unit economics and extend their runway, pivoting vendors often aggressively raise prices for existing customers, breaking multi-year budget forecasts and forcing unexpected renegotiations.
Okay, failure mode B, the shutdown and liquidation. This is the hard stop, exemplified by Artifact and Tome.
Artifact was the news app founded by the co-founders of Instagram, a team with the highest possible pedigree and, by all accounts, superior technology. Yet they shut it down because the founders concluded the market opportunity isn't big enough to warrant continued investment. Similarly, Tome, an innovative AI-powered presentation tool, laid off virtually its entire workforce in 2024 to explore strategic options, which effectively means shutting down daily operations and scaling back to a corporate zombie state while they search for a buyer.
The impact here is purely catastrophic. Immediate data loss and workflow disruption.
Absolutely. The main consequences are data loss and immediate workflow disruption. When a service shuts down, the mandated data export window is often extremely short. We're talking days, maybe a week. And if the vendor used proprietary data formats for storing your institutional knowledge, that knowledge becomes trapped in a dead format, unreadable by anything else.
And your teams are just stuck.
Suddenly, your teams cannot create presentations or documents or classify content, forcing a chaotic, painful migration back to legacy systems under extreme duress.
But the scariest aspect, the one that should concern the general counsel or the CISO the most, is the liquidation data trap.
This is a huge, underappreciated legal risk. When an AI startup files for bankruptcy, the trustee's fiduciary duty is to maximize value for the creditors. And often, the most valuable asset the startup possesses is the aggregated data it collected and trained its models on.
So, our data.
Your data. And in certain bankruptcy jurisdictions, Delaware being a notorious example, customer data, even highly sensitive data, can potentially be sold free and clear of the original privacy policies or contractual obligations to satisfy the vendor's debts.
Wait. So you're telling me my internal communication data, my proprietary documents, could be legally sold to a competitor or a data broker because the vendor I used went bust?
That is the risk. Unless your contract explicitly ring-fences that data and mandates deletion upon insolvency, or if the IP is structured correctly, which we'll get to later, that potential sale is a nightmarish multi-million-dollar compliance breach waiting to happen. And this risk alone should drive immediate architectural and legal decisions for every single enterprise.
And finally, failure mode C, the financial zombie, epitomized by Stability AI.
Stability AI, the company behind the popular Stable Diffusion models, faced a severe financial crisis in 2024. They had staggering reported debts to cloud providers like AWS and CoreWeave, and their internal projections showed them poised to lose $153 million against only $11 million in revenue.
They managed to bail out, but that period of instability must have created chaos.
Immense chaos and uncertainty for their large enterprise partners. Which brings the question, what does it mean to deal with a vendor that is technically alive but financially dead? They can still bill you, but the service suffers.
How so?
The quality of service degrades rapidly. First, you suffer reliability issues. Infrastructure costs are the single largest line item a distressed vendor can cut. This leads directly to chronic service outages, unpredictable latency spikes, and throttled API performance, all of which directly impact your integrated applications.
And you'd see a brain drain.
Severe brain drain. Top technical talent does not stick around at a sinking ship. That means the vendor's ability to maintain complex models, update security patches, or innovate degrades rapidly. And critically, you face license uncertainty. Desperate vendors may retroactively change licensing terms to claw back revenue, asserting ownership over content you generated or demanding payments for previously free usage.
Creating completely unexpected and expensive legal liabilities far down the line.
Exactly.
Okay, so we've established the scope of the problem. Now for the solution. What does all this volatility mean for our contracts? It's clear that standard SaaS agreements are wholly insufficient for handling these AI-specific financial and technical risks. We need what is essentially an AI prenup.
That's the only way to conceptualize this, and it requires a real shift in negotiating leverage. The current legal landscape is defined by what I call the liability squeeze. Enterprises are facing this dual threat that mandates strict legal firewalls.
On one side, you have courts expanding vendor accountability for algorithmic errors.
Absolutely. The precedent set by Mobley v. Workday is a major red flag for vendors and a key area for enterprise defense. In that discrimination suit, a federal judge allowed the case to proceed against Workday, the vendor, by classifying them as an agent of the employer.
Which means the enterprise can be held liable, but the vendor can also be brought into the lawsuit for the flaws in their algorithm.
Right. You can't just point the finger at the software developer and walk away anymore.
But at the same time, the vendor is trying to shift all of that liability back onto the customer through these broad, one-sided clauses.
They are. Standard AI contracts are riddled with broad indemnification clauses that require you, the customer, to defend the vendor against claims arising from your use of the AI. Essentially, the enterprise becomes the insurer of the vendor's algorithmic flaws.
Including things like copyright infringement or privacy violations built into the model.
Yes. And the ultimate liability trap is the vendor liability cap, which is often limited to a laughably small amount, typically 12 months of fees. So if an AI error causes a multi-million-dollar compliance breach, a massive class action discrimination suit, or a giant copyright claim,
You're left holding the bag for everything beyond that tiny cap.
you're on your own. This means the contract must be built to survive insolvency. The first, and arguably most important clause for resilience, is the model escrow clause.
And traditional source code escrow is useless here.
Practically useless for AI. Getting the Python files won't help you if you can't run the model. What you need access to, in the event of insolvency or service cessation, are three complex things that constitute the core intellectual property. First, the model weights, the actual learned parameters of the fine-tuned model. Second, the training data pipeline, the processes and specific code that you use to train that model. And third, the complete inference environment configuration, meaning the Docker containers, dependencies, and all the infrastructure recipes you need to bring that model back online in your own environment.
So the contract has to mandate the secure storage and release of that IP, but storing model weights sounds like a massive technical challenge, not just a legal one.
It is. We are talking about terabytes of data, potentially petabytes if you include the training data set. You cannot rely on a standard legal firm's escrow service for this.
You need a specialist.
You must use specialized AI escrow providers like NCC Group or Escrow London, who have the technical capability to verify, store, and regularly refresh these massive model weights, training pipelines, and configuration files. This investment is not optional for any mission-critical application. It ensures you have the technical blueprints to stand up the service internally if the vendor disappears.
The second essential clause goes right back to that liquidation data trap we discussed, the no training and data segregation clause.
You have to explicitly state that you, the customer, retain full ownership of all your inputs, prompts, and fine-tuning data, and that this data must not be commingled with the vendor's general training pool or used to improve their models for other customers.
The legal language needs to be airtight.
It has to be crystal clear and aggressive. Vendors shall not use customer data to train, fine-tune, or improve its foundational models, or for the benefit of any third party. Customer data shall remain the sole property of customer and must be verified as deleted upon termination or insolvency.
Right.
This is how you legally ring-fence your proprietary institutional memory.
And to prevent that hard light switch scenario where the service just goes dark overnight, we need the transition assistance covenant.
This is absolutely non-negotiable for any critical system. You have to mandate a minimum negotiated transition period. We recommend at least 90 days post-termination, during which the vendor must keep APIs active, maintain support, and provide active assistance with data migration and replatforming.
This prevents that immediate catastrophic workflow breakdown.
And it buys your technical teams the time they need to execute the model escrow plan.
Finally, we need to think about legal structuring specifically to navigate U.S. bankruptcy courts.
This is a complex but vital maneuver. When a software company files for bankruptcy, your contract is often considered an executory contract that the trustee can just reject to save money.
But there's a loophole.
There is. U.S. Bankruptcy Code Section 365N offers critical protection for licensees of intellectual property. The legal problem is that it's ambiguous, whether standard SAS access or even model weights fully qualify as IP under that statute.
So you have to structure the agreement carefully.
Your legal counsel must structure the entire agreement as a license to intellectual property, the model weights, the inference logic, rather than just a service agreement for accessing compute. This maximizes your chance of successfully invoking those 365N protections, allowing you to retain usage rights even if the vendor's company collapses around you.
So if I'm the general counsel, I don't care about the operational contract as much as making sure I have a perpetual legal right to run the model and access the IP for the next 5 years, even if the vendor's office is completely empty.
That is exactly the goal. You are buying the ability to use the underlying IP long after the vendor's cash runway has expired.
So if a server goes dark or a founder gets acqui-hired, a contract, even a great one, isn't going to bring the service back online. The most robust defense is architectural.
It has to be.
It's about designing systems that operate under the explicit assumption that vendor failure is not just possible, but inevitable. This feels like the ultimate form of resilience.
This is where enterprises shift control from the legal department back to the engineering team. And the single most effective architectural pattern for mitigating vendor failure and protecting against that inference cost trap is the implementation of an LLM gateway.
Okay, define the LLM gateway for us again, but tell us how it goes beyond just simple API routing.
An LLM gateway is a crucial middleware layer. Think of it as a sophisticated traffic cop that sits between your enterprise applications and the various AI model providers. Instead of your developers hard-coding a call directly to a specific vendor's API, say Anthropic.com, completions, they call the gateway instead.
And the gateway makes the decision on where to send the request.
Right. It routes that request based on complex configurable policies. And this allows for far more than just failover. It allows for advanced cost optimization, compliance checks, and load balancing.
So the gateway can make intelligent routing decisions based on real-time factors like cost and latency.
Precisely. You can set a policy that says, route all general support queries to Model A if the latency is below 500 meters and the cost is less than $1 per 1,000 tokens. But if Model A fails, or if the request contains sensitive PII, immediately route it to our internally hosted, compliance-vetted Model B.
That gives the enterprise a huge amount of control over cost and risk.
It lets you dramatically reduce your average inference cost and ensure compliance, all while managing vendor risk. If a vendor spikes their prices or suffers an outage, you just update the routing configuration in the gateway to switch to a fallback, say, an internally hosted Llama 3 instance or Azure OpenAI, without rewriting a single line of application code.
But to make that LLM gateway strategy effective, the underlying application logic has to embrace true model agnosticism.
It has to.
This means developers have to actively avoid prompt engineering that relies on the quirks, the biases, or the specific syntax of a single model.
Yes, over-optimizing for a single model like GPT-4 is a fatal mistake in this volatile environment. It creates immediate lock-in. To ensure you can switch models rapidly and safely, you must maintain a golden data set of evaluation prompts and expected outputs.
This is the foundation of evaluation-driven development.
And it's the only way to verify performance continuity.
Okay, explain how that golden data set works in practice during a crisis.
When your primary vendor looks shaky, or if you need to switch models for cost or compliance reasons, you use this golden data set, a set of known good inputs and outputs that are relevant to your business domain, to run an automated eval process against the new model. So, say, switching from Claude to Gemini.
And you're using automated metrics to judge the quality.
Exactly. You use metrics like ARDA scores for summarization quality, F1 scores for factual extraction accuracy, and coherence scores. You only greenlight the switch in the LLM gateway when the new model's performance on your proprietary dataset meets or exceeds the required threshold.
So it removes the guesswork and ensures quality.
It does. And critical applications must also have a pre-configured backup brain, a system where, in a failover, the gateway automatically routes to a highly reliable general model like GPT-4o, using a specialized simplified system prompt just to maintain core functionality while the engineering team addresses the primary issue.
The final, most powerful strategy against vendor lock-in and liquidation risk. It feels at the philosophical core of our whole deep dive. Own the data, rent the intelligence.
This is the ultimate defense against becoming a hostage of your vendors. Enterprises should absolutely avoid storing their proprietary knowledge base solely within a vendor's proprietary vector database or RH system.
Because if the vendor holds your institutional memory, your switching costs are astronomical.
They are. Moving hundreds of terabytes of vectorized data is a monumental task.
So the enterprise has to maintain data sovereignty. What's the resilient architecture for that?
The enterprise must build a proprietary internal knowledge graph or vector store using standard, portable, and easily swappable tools like Pinecone, Milvus, or even pgvector built on top of your existing Postgres database.
So the vendor is only used for reasoning, not for memory.
The vendor is used for reasoning, inference, based on the context you provide, not for memory, storage, and retrieval. You maintain complete data sovereignty, you hold the memory internally, and you send relevant ring-fenced context to any AI vendor you choose for processing. If you do this, the vendor instantly becomes a commoditized, swappable utility.
Which massively reduces your switching costs and protects you completely from their financial collapse or those data liquidation traps.
Completely.
Yeah.
So before you sign that $500,000 contract, your due diligence needs to be far more rigorous than just standard security questionnaires. You need to assess viability and replaceability as if your business depended on it. Because, frankly, it does.
Let's start with the financial viability stress test. Now, startups hate giving away financial metrics, but we have to demand transparency, even if it's using proxies.
You need to ask the founders or the CFO directly about their efficiency metrics, and you need to demand specific, non-hedged answers. The critical question is the burn multiple inquiry.
So you just ask them straight up.
You ask them, is your burn multiple under 2.0x, or preferably under 1.0x? And, crucially, do you have at least 18 months of runway at your current burn rates? Not based on some wildly optimistic projected revenue growth. If they hedge or rely on vague projections, that is a massive, immediate red flag signaling distress.
We also need to look at the quality of their backing the investor syndicate as a proxy for their survival strength.
That matters immensely in a downturn. Are they backed by Tier 1 VCs, Sequoia, A16T's benchmark? These firms have the deep pockets, the strategic intent, and the fiduciary responsibility to support a portfolio company through a downturn and keep them afloat, or at least orchestrate a clean exit.
Versus being backed by tourist investors.
Exactly. If they're backed by tourist investors, hedge funds, or crossover funds that were just looking for a quick flip, they're far more likely to be cut off when the market tightens, which immediately forces the company into that financial zombie mode.
And you can monitor their headcount.
You can. Monitor headcount trends using public data sources like LinkedIn. A sudden freeze, or worse, a decline in engineering headcount, often signals financial distress and is a clear canary in the coal mine, preceding a collapse or a major painful pivot like we saw with Jasper.
Now, for the crucial technical wrapper audit checklist, we need concrete proof of their technical depth.
First, you have to perform a thorough dependency mapping. List every single third-party API the product relies on, from the foundational models to auxiliary services like translation or speech-to-text. If they are 100% dependent on a single provider, say the OpenAI API, the risk of Sherlocking and total failure is extremely high. The vendor is not architecture-proofed.
And the most important check, fine-tuning verification. They have to prove they are more than just clever prompt writers.
You have to demand concrete, technical evidence of proprietary training. Ask them to prove it by showing their internal artifacts. Show us the loss curves from your training runs, which illustrate how their model improves over epochs.
You can also ask about their evaluation data.
Right. Ask, what is the size of your proprietary evaluation dataset, and how often do you run evaluations? They can't provide these highly technical, specific answers, or if they just show you pretty dashboards, they are likely just applying a thin wrapper around a public model.
We also have to perform a data lineage audit to protect against that massive future legal exposure, particularly the copyright risk.
Absolutely, you must ask, where exactly does your model's training data come from? And can you prove you have the necessary licenses and rights to use that data? This protects your enterprise from the risk of the model being legally challenged and potentially taken offline or deleted due to copyright infringement.
Which is a huge risk highlighted by ongoing cases like New York Times v. OpenAI.
It is. If the underlying foundation model is legally challenged, your entire service vanishes, so you need certainty on data lineage.
And finally, for early-stage startups, assessing the bus factor is critical to mitigating that acquire higher risk.
The bus factor is a grim but necessary reality check. How many key people must be hit by a bus for the entire project to fail? For small, deep tech startups, this number is often 1 or 2. typically the chief scientist and the head of engineering.
This is the human corollary to the acquihire problem.
It is. So, to mitigate this risk, enterprises must negotiate a key person clause. This clause grants immediate mandatory termination rights, or even better, immediate access to all those escrowed materials if those critical founders or engineers leave the company. This protects you from the scenario where a rival absorbs the technical talent and leaves you completely stranded with an unmaintained product.
This has been a deeply detailed look at an incredibly volatile market. And the AI vendor shakeout is not some theoretical problem. It's an imminent restructuring that requires immediate action. To summarize our strategic recommendations, enterprises must adopt a portfolio approach to distribute risk. You have to mandate prenups in all AI contracts that guarantee model and data access. And fundamentally, you must invest in sovereign AI architecture.
That means implementing LLM gateways and proprietary vector databases.
Exactly.
The consolidation wave is inevitable, and it will be painful. It's going to result in billions of dollars of stranded VC investment and orphaned, unmaintained technologies. But for the enterprise buyer, who is prepared, who performs diligent financial stress tests, mandates strong legal firewalls, and builds resilient, model-agnostic architecture, this shakeout is not just a threat.
It's an opportunity.
It is a necessary, critical opportunity to mature your entire AI strategy, moving from chaotic experimentation to disciplined, industrial scalability, and really seizing control of your own destiny.
Okay, let's leave you with this provocative thought. If owning your data is the ultimate last-mile defense against vendor failure and liability, is the true competitive advantage in the next decade going to be measured not by how fast you adopt AI, but by how rigorously and intelligently you protect your organization's institutional memory and data sovereignty from the very systems and vendors you rely on to generate intelligence? That's something to mull over. Thank you for joining us for this deep dive. We'll see you next time.